Welcome everyone, new WebPro edition November. Very excited with today's presentation. We were contacted by Lanita saying one of her superstar student workers put together, I've been experimenting with Docker. So Connor will come up and give us a one-on-one on that and give a little intro, maybe how you guys, your team got into that as well. And without further ado, I'll let him come on up.
Hi everybody, my name is Connor Swann. I'm a student worker with Information Security. And I'm here to talk to you guys about Docker. So just full disclosure, I actually stole these slides from another guy. He open sourced them. And those slides were stolen from Docker themselves. We did the due diligence of updating them to today. So it should be relatively up to date as of about 2 weeks ago. So since Docker started in 2013, it's got 500,000 pulls, 1,000 unique contributors, thousands of Dockerized applications. Pretty much any application you could possibly ever want to run runs in Docker. Integration with all the IT automation solutions, and there's meetups around the world. There's a lot of real big names that have bought into Docker. It's a really robust, really large active project. So the challenge with IT in general is on the top portion of this graph, you've got all your different applications and software that you need to run. On the bottom, you have got all the hardware that it needs to run on. You go from development to testing to production to clients stuff. There's a lot of stuff going on there. It's a matrix from hell, really. Each of these little boxes is how do I run blank in the left column on blank on the bottom. So how do I run my static website on my development machine? How do I run my static website on the customer's hardware? And each one of those has its own solution. It's really analogous to cargo transport. On the top portion, you've got all the stuff you need to transport. And on the bottom, you've got all the different ways to transport it. It's also a matrix from hell. How do I transport blank using blank? The solution for shipping was the intermodal shipping container. It allowed you to worry about how to put your stuff inside of the container, and then somebody else will worry about how to ship the container on your means of transportation. It was a standard container, everybody agreed on it, and it revolutionized shipping. Docker is a container system for code. It allows the developers to worry about how to get your stuff into the Docker container, all your dependencies, all your code, and then it allows the systems administrators and the hardware guys to worry about how Docker runs on their machines. It abstracts away any software setup. Docker eliminates the matrix from hell. How do I run my static website on my development VM? Docker. How do I run my static website on the customer's machine? Docker. So why would developers care? Build once, run anywhere. It's safe, clean, hygienic, portable runtime. You don't have to clutter any of your development machines, for example, with dependencies. And that's really huge. I've had 2 different versions of Python before that have interfered with each other, and that's just a pain in the butt. You don't have to worry about missing dependencies, because once you've installed it and it works, it doesn't disappear. It stays within the Docker container. Each app is in its own isolated container. You don't have to worry about dependencies from one application messing with dependencies from another application. You can actually run 3 versions of MySQL on the same host, and they don't conflict with each other. You can automate testing, integration, packaging, anything you can really script. Docker has a full API that allows you to automate stuff. And with the automate testing and integration, as I mentioned earlier, all the big IT automation software plug in with Docker out of the box. And then you can eliminate concerns about compatibility on different platforms because, in a sense, you're just running it inside of Docker. If Docker works, it works. Just a little footnote at the bottom there. Anywhere means an x86 server running modern Linux kernel, or more recently a Windows host. Windows has just released their Windows Server containers and their Hyper-V containers. Both of those are compatible directly with Docker. They use the Open Container Standard. More on that in a little bit.
So would you have to use different mechanism for expiring that off, like with a Linux system, for example, you might use CoreOS or something as a launch mechanism, whereas with Windows you would need something separate, or how does that work?
Each one will use the Docker engine, so it's the same Docker commands on any host. It's the Docker engine.
But for Windows support, you'd have to build it under something else to support it.
I'm not sure I quite understand that question.
For example, in Linux, you would use like CoreOS as your mechanism under which you would create your various containers. So is there a similar kind of a mechanism for Windows under which that occurs?
As I understand it, the mechanism is abstracted away. It generates a container using the same format on any host, regardless of the underlying operating system. So the Windows mechanism for generating containers will create the same container as a CoreOS mechanism that's generating a container.
Oh.
And then the engine knows how to run those containers, so you can then just drop it on any host, and the operating system calls are abstracted away. Does that answer your question?
Mm-hmm.
Cool.
Yeah, thank you.
And zero penalty containers. The building is really lightweight. It's like a VM without the overhead of a VM. I'll get to that in a little bit. It gets rid of the operating system entirely within the image. Why administrators care? Makes the entire lifecycle more efficient. Once your developers have their app working, debugged completely, they stick it in the container on their development machine, they upload it to a central repository, and all the systems administrators got to do is install Docker, pull the image down, and then run it. This next one's questionable. Increases the quality of code produced by developers. I think it does. However, there's definitely, if you got a bad developer, you got a bad developer. It eliminates inconsistencies between development, test, production, and customer environments. Sometimes you build out your test server, you've got version 3.5 of MySQL, and then 2 months later when you're provisioning your production server, it's version 3.8. It doesn't really become apparent to you because you didn't check, what version did I have on the test server? You just install MySQL. With this, the version that was installed with your application stays with your application throughout its entire lifecycle. Supports segregation of duties. If you've got a container for a database, you've got a container for your application, you've got a container for this and that and the other thing, it allows you to debug and segregate the different parts of your application and your service. Kind of mentioned that already. Whoops. Yeah, because the containers are so lightweight, it addresses significant performance, cost deployment, portability issues. VMs are thirsty for hardware in general. Docker eliminates a lot of those concerns. So you can run it anywhere regardless of kernel vision. If it runs the Docker engine, I know I'm reiterating this a lot, if it runs the Docker engine, it runs. Regardless of host distro, I can run a Red Hat Linux Docker container on an Ubuntu server. I can run a Ubuntu server on a Windows host now. It doesn't matter what the host operating system is. Virtual Cloud Physical, I've run Docker on Amazon Web Services. I run Docker on my personal computer. I've run Docker everywhere. If it can run on the host, it can run on the container. If you run on a little Linux kernel, it can run. At the high level, it's a lightweight VM. I use it to, if I want to figure out how I would provision my personal server, I am going to download the Ubuntu container, run it on my computer, and check how it would work before I actually deploy. It's got its own network interface. The containers themselves, if you've got multiple containers running, they are networked within each other. So you can talk to the containers without actually leaving your computer. And the containers can talk to themselves. can run stuff as root. It's got its own sbin/init, so when you're starting it, it's completely, if you change startup stuff within the container, it doesn't change stuff on the host machine. At the low level, it's like true on steroids. What it really does is it jails a process to a folder. So it doesn't have access to anything outside of that folder. And the Docker engine is what does the kernel calls. Yeah. So VMs versus containers. On the left side of this diagram, we've got the VM. VM has got your app. It's got bins and libraries. It's also got the operating system. If you want to change this, you've got to make a copy of the entire operating system and then change your application. This is app. This is changes to your app, and this is a completely different application. On the right side of this graph, we've got the Docker implementation. Docker allows you to share the underlying file system between containers. So if I want to make a copy of my application, it's totally possible. If I want to make changes to the application, it only changes the affected parts of the file system, effectively reducing duplication. So for those of you who are on Skype, this left side is the VM implementation. This right side is the container implementation. So why exactly are Docker containers lightweight? I just kind of dived into that a little bit. But with the VM, you've got to copy the entire operating system, all the bins and libraries, all the junk. However, with Docker, it's only this little sliver that's changed that is then pushed to the repository and then distributed to all of your servers. The life cycle is the life cycle looks a little bit like this. You start with your Docker file on the left side. The Docker engine consumes the Docker file and builds a container. The container then that's the end of the life cycle if you're not really worrying about a central repository. However, if you would like to deal with the central Docker repository, you can push your image to Docker Hub, which is what they're calling it, and then pull it down to your host machine and then run it. It allows you to have a central repository for base containers and stuff like that. Changes and updates look like this. You change your application, but you don't change any libraries. And then the next one, you change a library, you don't change any part of the application. It grabs those changes, pushes them to Docker Hub, and the only thing that gets pulled down are the differences. So the updating doesn't require you to download an entire new VM image. All it does is have this little sliver of the file system. So I've got a little bit of a demo. However, it's a little bit different than when I wrote this presentation. This kind of shows the build process. You don't really need to worry about what it says, but it builds. However, the fun little tidbit here is that this presentation is written in web technologies, which is kind of fitting for the WebPro meeting. I've got a little web server running inside of Docker. However, I wrote this presentation on my personal computer, and we needed to be able to stream it to all you lovely people watching from home. So I said, hey, how are we going to run this presentation? And then I realized that I built it in Docker. So I saved the image, uploaded it to Docker Hub, sent it over, and he downloaded it onto his machine, and it works exactly as I would have expected it to, which is kind of a really interesting and cool proof of concept for Docker in general.
We had one fun moment before, because before we did the image, he sent over kind of like the description of how to build it. And you will find there are some nuances of differences with Windows, especially when Windows needs to talk to an Ubuntu container. And then we were having some fun with getting these share volumes between the two environments to talk. There is a way to tell the container, I want you to have a share on the host. So you could kind of hot reload your web app. And of course, Windows and how it does pathing and how Nix does pathing. A little tricky, not impossible, but we just said forget it because we were having a challenge with it and went with the image. And it
Yeah.
worked flawlessly.
Exactly. So it actually ended up being a two-step process. For those of you here, I told him to clone the repository that I made on GitHub and run it using Docker Compose. It's a utility that's part of the Docker suite. That didn't really work, so I ended up just having him pull the actual image, which is here, and then running it using this nifty little command right here. So 2 steps: pull it, 30-second download, and then running it immediately. Which, as all of you probably know, that's kind of miraculous when it comes to web technologies and servers in general. So, what does Docker play well with? The answer to that is pretty much anything. Any Linux distribution under the sun. Core OS, as Tobias so lovingly talks about all the time. Got your OpenStack, private platform as a service providers, Rackspace, OpenStack, Baidu, which is the Chinese Amazon, infrastructure as a service, DigitalOcean, Amazon Web Services. Amazon Web Services actually build out an entire infrastructure on top of Docker called their Amazon Machine Images. Those are super cool. You can run any operating system you want, and it takes like 2 minutes to provision a new server. DevOps tools such as Chef, Puppet, Jenkins. I have personally used Jenkins with Docker. It allows you to create a new testing machine every time somebody pushes to the code repository, which is definitely a novel thing to have. And like I said earlier, there's literally thousands of Docker's been around a long time, since 2013, and in that time, people have built pretty much any application you could possibly run. I use the MySQL container a lot. I use the Ubuntu container a lot. And it's just somebody has built this Docker image and then uploaded it publicly for anybody to use. So Docker project status. A couple weeks ago, they released Docker 1.8. They're now signing images, so you can trust that the image that you're downloading is the image that you actually wanted. They recently released the Docker Toolbox. The Docker Toolbox makes it trivial to run Docker, even if you're not super versed in how the command line works in general. They have graphical user interfaces that allow you to just spin up and spin down Docker containers. The entire Docker.io website, the experience is phenomenal right now. When I started learning Docker, the documentation left much to be desired. However, it sounds like they just hired, 5 or 6 new designers to make their documentation beautiful. Companion projects to Docker are Docker Compose, Docker Machine, Docker Swarm, Kitematic. Kitematic is the graphical user interface. Docker Compose allows you to build multi-container setups. So you can potentially run an entire simulated network on your machine. So if you wanted to test interaction between multiple applications, you can do that. Here's a couple links for you. There's a GitHub. There's an IRC. I hang out in the IRC a lot. Hang out in the IRC a lot. I go by Tai, T-A-I. So if you see me, say hi. Yeah, so that's Docker. Are there any questions? That was a lot of information to kind of just throw at you. Yes.
All right, so that makes sense to me, moving your full stack around, right? So that you've got your web server and database and that, and you moved around like a little lamp and the kind of system moved around. What would the structure look like when you're dealing with databases that are architected out and separate?
Yeah, so that's actually a really good question. Over the summer, I've actually had firsthand experience doing this. We had our dev environment with our dev MySQL database and our dev Mongo database, and those were running within containers. We had fixtures for those, and we could mutate the database and tear it down and do all the sort of developy sort of stuff. Then we had a live database hosted with Amazon, and it was a Python application. It was Django. The Python application was configured to look for strings in environment variables. So the container, by default, as part of the ecosystem, allows you to set environment variables as it starts. So in production, the container was pointed towards the production MySQL database, and in development, it was pointed towards the development MySQL database.
Do you see instances of this? We all talked about, I mean, these examples, a container moving around, but it's also, I guess, understood that containers get pieced together. So if there's a database container, maybe that moves as well.
Yeah, exactly.
I guess you have the freedom to architect it however you want.
Yeah. The cool thing is that you can open up ports and close ports and route traffic by name, essentially. You name the container, and then it allows you to then route traffic and packets throughout the virtual network.
So in that respect, is there a way if you have multiple containers that have interdependencies on each other that you can either formally or informally somehow bundle them together so that you know that if you need to move one to a totally different location somewhere else, that you can be sure that all the proper pieces go along with it?
Yes. So say you've got, I don't really know exactly what kind of situation would warrant that, but say you've got...
a web server on a database, for example.
Well, how about this? How about your web server and your database are both running on Ubuntu hosts? So they both rely on the Ubuntu file system and the Ubuntu kernel and all of the bins and libraries that go along with that. You download the Ubuntu container, and then it shares that file system between the two. So it literally forks and allows both containers running at the same time to use the same write-only file system. And then if you need to move those, obviously the space savings aren't there anymore because you've made a complete duplicate of the Ubuntu operating system. But it allows you to then move that to a different host. Is that kind of...
As long as the target host already has an Ubuntu platform on which to run.
Not necessarily.
Or would you move it along with it?
Yeah, so the Ubuntu container comes with it.
Oh, I see. Okay.
And it's not really a full Ubuntu install.
Right.
It's everything but the kernel. The kernel is the most, space intensive part of that.
So you're making a larger ecosystem now.
Larger. The Ubuntu image is like 300 megs or something. It's not a whole lot of overhead.
But as opposed to having to move containers and know that I have dependent containers.
Yeah.
I think that's what we realize.
The thing is
can't move this container without the other one.
Well, I think
exactly. I guess the other question is how do you, do you have to track that yourself in terms of the container interdependencies on each other?
Yeah, the container itself is what tracks its dependencies. You say, hey, I need the Ubuntu container, and then it says, okay, cool. Now if you move me around, I'm going to bring all of my dependencies with me.
So would it also bring the SQL component along with it, which might be in a separate container?
If it's a code dependency, yes.
Oh, okay.
But if it's a network dependency, like, hey, I need to talk to a MySQL server,
gotcha.
That's up to the developer to configure.
I see. Okay.
Yeah, and I think that's a little bit of the goal of also Docker Compose.
Yeah.
Is that you can kind of script up. I've got all these microservices. Obviously, it will create all new containers. You'll have to restore data and all those things, which you can then script as well. And I think that's the main goal behind Docker Compose. Yeah, it's pretty nice.
Yeah, that's Docker. It's really cool. I encourage you guys to all use it. I use it all the time.
All right, so let's talk about it from a developer sitting at a desk and contributing to source code. And they have GitHub repository where they do code, and then you have the Docker image. It's also in its own repository. When I make changes to code and I want to commit that to the repository, is that independent?
Yeah. So
it still happens like normal and then down the screen.
The hardware, it's not actually hardware, the Docker container I'm referring to as hardware.
Right.
The hardware build and the software build is completely separate from the code that you're writing. So in my experience, I have built the container that has all my dependencies. So say it's a Python project. I'll install the Python dependencies. I'll install all my Node dependencies on the machine, on the container itself. And then I will mount part of the file system from that container. You don't have to worry about how it's possible, or you just mount it as it is. You mount a file from within the container to the host system. In the build process, the code has been pulled. The code from your application has been pulled down from GitHub onto the machine itself, and then it mirrors the file that is storing your Git code to the host. So you can edit it in your normal text editor, what have you. Any changes that you make are then mirrored directly to the container with all the runtime dependencies.
Okay, so that makes sense locally. So then when I publish that container and it goes to developer B, they pull it down. Does Compose then reset up all those structures and environment? And how did they connect their GitHub instance? How do they get the same setup?
Yeah. So when you're getting ready to deploy, you take your normal, your setup with the mirroring and stuff like that. That's superfluous for a production machine. So you get rid of the mirroring, you clone your code directly to the machine, or to the container, and then you commit it.
It's almost exactly what we were originally doing.
Exactly.
He sent me the Docker Compose, but only because of the idiosyncrasy of the Windows way I'm a rookie at Docker. The volume wasn't working right. And he was like, well, I'm done with the presentation anyway, so I'll just do the image.
So I effectively deployed it to his machine.
But the instruction for Docker Compose was, well, go get the latest source first, from GitHub. And in that, I have the Docker Compose file and, run the commands, and you'll get your container built. And in his case, he had it hooked up to his local host source file. But that mapping didn't work right on my box because it was Windows versus OS X. And I just didn't have time to play with that. Microsoft and them have documentation on it, and they agree that's a bit of a sore spot right now still for the Windows ecosystem, which is the volume share mounting.
Okay. So I'm working locally, and that share, so it's connecting it to the Docker image.
Precisely.
That's what
So effectively in development, you're soft coding your code into the Docker container.
Yeah.
And in production, and when you're deploying it, you hard code your code within the Docker container, and then you push that out. So all of your dependencies and your application code are contained within the container and image.
All that can be scripted.
It's 100% scriptable.
Right.